So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are going to talk about this crazy integral. And you know what? Like, this video is going to be the first part of the evaluation of this integral, but we are going to evaluate this on in another way, but that another way's proof would be in the next video. And for now, let's just evaluate using some elementary things like just playing with some algebra, and we would be getting our answer too early. But you know what? With the second method that I'm just going to propose it into the next video, and that too on my board, because that is a quite long video and I just need to express everything by just looking at in your eyes, and that's why I would choose to just teach that on board. But now let's just make some base of this integral, right? And let me just spark a curiosity of this integral in you. You know what, you might have seen one of my videos in which I have evaluated, oh wait a second, this integral x to the, I think it was n minus 1, or let's say m minus 1 over 1 plus x dx was proven to pi over sine m pi. So yeah, I have proved this in one of my early videos, and that was really great. And you know what? I have proved this, like, it was really tough to prove. And I think I would just say that this is one of the toughest integrals that I have proved, because you cannot directly prove this integral to this result, but you have to go through with some infinite sums and a lot of things. Like you if you want to just check that proof, you just have to check through that video, or I would consider just taking that videos link in the description box of that video in this video, right? Okay, so basically this is what it is. And you know what, but there are some things which ain't here, like matching, like why I'm discussing this integral in this video, because if we are here to talk about this integrals, right? Okay, let's just try out something with this as well here. So let's say that I just want to evaluate this integral x to the m minus 1 over 1 plus x to the n. Basically I'm just replacing this x with x to the n, right? So how are we gonna do that? So basically for this integral, let x to the n equals t. Okay, so when you take the derivative, so it's n times x to the n minus 1 dx is dt, right? Okay, so if you talk about dx, so it's dt over n times x to the n minus 1, right? Okay, so now let's just replace our stuffs. And you know what, here when you plug x equals infinity, so basically t is also going to be infinity, and 0, it also 0. Basically it's not bothering our limits of this of our integral. So yeah, so here x is, let me just calculate x from this equation as well. So basically x is gonna be t to the 1 over n. So it's gonna be t to the 1 over n whole to the m minus 1 over it's 1 plus t, and your dt is n times x to the n, oh I'm sorry, well x to the n is t, right? And x to the, well, 1 over x means 1 over t to the negative n. So basically it is t over t to the 1 over n. So this is what we are having. So basically it's just basics of exponents, so you can just tackle that out if you are having any kind of trouble understanding this, because it's not difficult to understand. So when you just expand this, so it's t to the m over n times t to the negative 1 over n, and this is going to be multiplied to numerator as well. So this is t to the 1 over n dt, and well, since n is a constant, so that's gonna be plugged out of this integral, and we are having it's 1 plus t times t. Fine. Okay, So now very good cancellation here, that we got rid of this t to the 1 over n and t to the negative 1 over n, and we are having 1 over n times integral from 0 to infinity of t to the m over n. Well, since I can just write this as t to the negative 1, and when we combine this, so we're gonna have m over n minus 1 in the new exponents of t, and it's 1 over t dt. And you know what, if we talk about this very integral, so this is the like we have replaced m with m over n, that is, it is going to be evaluated to sine of pi, pi over sine of m over n pi. From this very relation, you just have replaced this m with m over n, so that's gonna be m over n here as well. So basically we can say that it's 1 over n as a factor, and it's pi over sine of m over n pi. Hence you can say that integral from 0 to infinity of x to the m minus 1 over 1 plus x to the n dx evaluates to pi over sine of its m pi over n. So again, I haven't talked about this very integral in that video in which I have proved this one, but yeah, here we are good to go with this. And now we can talk about this very integral when we are talking about the integral from 0 to infinity. So that's gonna be integral from 0 to infinity of this is the numerator is 1. So if we want to make this numerator as 1, so we have to just plug m equals 1, because x to the 0 is 1, right? And for the denominator we have to plug n equals 4 here. So basically it's dx over x to the 1 plus x to the 4th, and it's pi over n was 4. I'm sorry, I just forgot the n factor here. Okay, 1 over n actually. So n was 4, the 4 times sine of m was 1 right here. You just have to plug m equals 1 in order to get 1 in the numerator as well, right? Okay, so it's pi over 4, so it's gonna be pi over 4 times 1 over square root of 2, that is basically pi over 2 root 2. Okay, so basically we can say that integral from 0 to infinity of 1 over 1 plus x to the 4th dx is pi over 2 root 2, right? So yeah, but we are not here to talk about this, but still I just explained you that. And now let's talk about the integral that we are here for. Okay, so yeah, this is what we're having right so far. So how are we gonna do that? But well, if you got any kind of integral which is being evaluated from 0 to infinity in terms of like some algebras, right? Because when you talk about doing that integral with elementary steps, the way we are going to do this, you cannot do that, because the limits are not something like that, because infinity will bother us. So for that you just have to remember this formula, or you can just consider watching the proof of this formula or this integrals. That's really amazing. Okay, now let's just dive into it. Well, we can just consider this as I firstly, and let's just jump into it. So I equals integral of dx over 1 plus x to the 4th. Well, I can just multiply and divide with 2 in this integral, so that's gonna give us 2 times dx over 1 plus x to the 4th, right? Okay, now let me just do here some manipulations, right? Okay, let me just do that. Yep. So I can write this as x square plus 1 and plus, oh wait a second, I think I'm sorry, I think I should consider writing it something like this: 1 plus x square and plus 1 minus x square, something like that. And then we are having 1 plus x to the 4th dx, because when you solve this, so x square minus x square got cancelled out, and we would be having 1 plus 1, which is 2. So yeah, we are just having the same result that we had earlier. Next, I equals 1 over 2. We can split this into two separate integrals as well here. So basically that's going to be 1 plus x squared over 1 plus x to the fourth, the first one, and then 1 over 2 the factor and times the integral of 1 minus x square over 1 plus x to the fourth dx. Okay, and now in both the cases we are just going to do something here, that is, wait a second, divide both numerator and denominator by x squared in both cases. So let's just do that here. So basically we are gonna have 1 over 2, 1 plus x squared over x squared dividing with x to the 2 as we have written over there dx, and so for the next case 1 minus x squared over x squared and then 1 over x to the fourth over x squared dx. Fine. So we can just write this as 1 over 2 integral, it's 1 over x squared plus 1 over, it's 1 over x squared plus x squared, right? And plus 1 over 2 integral 1 over x squared minus 1 over, it's 1 over x squared plus x squared dx. It's pretty much fine, right? And now for the second integral I'm just gonna bring a negative in front, and which is going to change the order of this numerator. So basically it's 1 plus 1 over x squared. Well, we can write this as, yeah, it's pretty fine. Let's just do something different here. And yeah, oh, I think I should have taken a negative in front, and it's 1 minus 1 over x squared, and it's 1 over x squared plus x squared dx. Okay, so it's pretty much fine so far. Okay, now we are just going to do something here. Let's just talk about that. So important to note. Okay, so if we talk about the expansion of 1x plus 1 over x whole square, so it's x squared plus 2 plus 1 over x squared. So from here we can see that x squared plus 1 over x squared can be written as x plus 1 over x whole squared minus 2. And I would like to just cover it slightly a little bit here. And if we talk about the second one, so it's basically first one, and if we talk about the second one, so it's x minus 1 over x whole squared, so it's x squared minus 2 plus 1 over x squared. So basically we can also say that x squared plus 1 over x squared can be written as x minus 1 over x whole square plus 2, right? Okay, so yeah, that's what we are having so far. Actually, I would like to just cover it something like this, because this is really important. Yeah, okay, so what I am trying to do something here, what I really want to do here is, well, since look at the factor of this one, of this thing, like I'm talking about the factor, I'm sorry, I'm really sorry about that, I'm not talking about the factor, but I'm talking about the derivative of x minus 1 over x. So basically it's the derivative of x minus the derivative of 1 over x, I'm sorry, x. So that's gonna be 1 and plus 1 over x squared, because the derivative of 1 over x is negative 1 over x squared. So that's gonna be the negative is gonna multiply to the negative in front, and that's gonna be positive 1 over x squared. And that is what we are having here. And if we talk about this one, if we talk about the derivative of this function, so that's gonna give us this one. So that's what we are going to do here. And yeah, that is why I chose this method, because this is quite convenient to solve through. So I is 1 over 2 integral. For this case, I'm just going to take this one actually on the place of 1 plus x squared plus x squared. So it's 1 plus 1 over x squared over, we can say it's x minus 1 over x whole squared, and it was plus 2 dx, right? Okay. And if we talk about with the negative 1/2 in front, and it's 1 minus 1 over x squared, and it's x plus 1 over x whole squared minus 2 dx. Okay, so that is what so far we are having here. And now if we talk about, let's say that it is your I1 and this is your I2. So if we talk about I1 firstly, so I1 is integral of 1 plus 1 over x squared over x minus 1 over x whole squared plus 2 dx. So I'm just going to consider here that x minus 1 over x equals t. So that's gonna give us 1 over x squared plus 1, I'm sorry, I have left dx here, dx it's dt. So yeah, this whole part becomes dt and this becomes t. So we are having our I1 as integral dt over its t squared plus we can write 2 as a square root of 2 whole squared, right? So well, since it's just a basic integral, it's the form of integral of 1 over 1, or maybe x squared plus a squared dx evaluates to 1 over a arctangent of x over a plus c. So this is the basic expansion or basic integral evaluation of this type of thing. The basically on the place of x we are having t for our case, and a is square root of 2. So let's just replace all the things with respect to that integral, with our integral actually. So it's I1 equals 1 over square root of 2 arctangent of its t over square root of 2 plus c, and we have to replace our t with the one that we have assumed earlier, that is 1 over square root of 2 arctangent of, it was x minus 1 over x over square root of 2 plus c. So finally we are having our I1 as 1 over square root of 2 arctangent of x minus 1 over square root of x plus c. I shouldn't writing the plus c because it's not the final evaluation of integral, but it's all right. It's just constant of integration, so we really don't care about that. Or we can just consider writing in the last, but it's all right. It doesn't bother us anymore. So our I1 evaluates to that much thing. Now let's talk about our I2. So I2 was the integral of 1 minus 1 over x squared over, it was x plus 1 over x whole squared minus 2 dx. And again we just have to let here x plus 1 over x as t. So that's gonna give us 1 minus 1 over x squared dx becomes dt. So basically our I2 comes out to be dt over t squared, and we can write this as square root of 2 whole squared. So this is another a basic or a fundamental integral which we know the result of. Actually it's the integral of 1 over x squared minus a squared dx. It is 1 over 2a times ln of x minus a over x plus a, or maybe because we should consider taking absolute part of this. Okay, so yeah, let's just expand this thoroughly with that. So our I2 here is gonna be 1 over 2 times square root of 2 times ln t minus square root of 2 over t plus square root of 2. And we can say that because we had assumed that t equals 1, I'm sorry, t equals x plus 1 over x. So just let's just replace with that. So it's 1 over 2 root 2 times ln x plus 1 over x minus square root of 2 over, wait a second, x plus 1 over x plus square root of 2. So finally I2 comes out to be, oh, I think I should just, yeah, so it's 1 over 2 root 2 ln of it's x squared minus square root of 2x plus 1 over x squared plus square root of 2x plus 1 and plus c. So this is what we are having so far, and this is the final result of the I2 that we had assumed from I actually. So now we are good to go with our final result for our integral, because we are having I1 here and we are having I2 as well. So we just have to plug here on the place of I1 and I2 because we had assumed it over there. So basically our I comes out to be 1 over 2 times I1, which evaluated to 1 over square root of 2 arc tangent of, it was x minus 1 over square root of 2x, right? Okay, and then minus 1 over 2 times 1 over 2 root 2 ln modulus or absolute value of x squared minus square root of 2x plus 1 over x squared plus square root of 2x plus 1, and we have to consider plus c as well here. So let's just expand it. So basically and finally we're having, it's 1 over 2 root 2 arc tangent of x minus 1 over square root of 2x and minus 1 over 4 root 2 ln of absolute value of x squared minus square root of 2x plus 1 over x squared plus square root of 2x plus 1 and plus c. So this is the final result for our integral that we are here for. And let me just write that down, that the integral of 1 over 1 plus x to the fourth evaluates to 1 over 2 root 2 arc tangent of x minus 1 over square root of 2x and minus, wait a second, minus 1 over 4 root 2 and natural logarithm of I'm sorry guys, natural logarithm of x squared minus square root of 2x plus 1 over x squared plus square root of 2x plus 1 plus c. So finally guys, we are done with this, and we did a lot of things in this video. And again, if you got to learn something from this video, just make sure to like, subscribe and share. And if you have any kind of doubt, please, you have to make sure to just ask me in the comment section. I'll reply that. I'll surely reply that. Don't be any kind of like, don't hesitate at all. Just assume me as your brother, or don't assume me as like a teacher. I'm just your brother. I'm just a brother of yours. That's it. I'm just a bro. That's it guys. So yeah, goodbye guys, take care. And I would like to just request you to just come up for the next video, because in that video we are gonna take something crazy. Let me just show you still, because maybe it's gonna help you to just bring you to my next video. So basically we are just going to evaluate this integral using the factor of 1 plus x to the fourth, and or more precisely, we are just going to evaluate this by partial fraction decomposition. But now I would like to just give you some homework so far, partial fraction decomposition, and the homework is decomposition. So the homework is, you just have to factor 1 plus x to the fourth. Factor it. And if you can factor this out, please just have to comment that factor that you have got by your own in the comment section of this video. And if it's slightly different from the one that I have seen the factor of this one, so I would just cover that factor as well for the next video, in the next video. So yeah, goodbye guys, take care and love you. And that's gonna be quite long video, but still I will make sure to just explain you a lot of things in deep as much as possible. Goodbye guys, love you.